All right, so let's try number 8 and 16.5, which should roughly be, what am I supposed to do?
Evaluate the triple integrals in cylindrical coordinates.
Okay, so calculate. Okay, so this might be the hardest cylindrical example we've done yet. Brace yourself. Okay. We're supposed to integrate a function of x, y, and z, which is sine of x squared plus y squared, over this w, which is this solid cylinder with height 4, radius 1, centered on the z-axis, and starting at z is -1. You got a picture of this thing in your head?
No.
Okay, what's a cylinder?
A can.
A can.
A 2.
Perfect. Picture a can of baked beans.
Okay.
What do you want? Salmon? What comes in cans? I don't know what you kids eat.
Spam.
It's not a spam can. Spam cans aren't round.
That's true.
Home style beans.
Okay, whatever. It's fine. We don't have to
cocktail?
picture whatever this is.
Okay.
We have a can. Keystone Light. What do you? Never mind.
Oh, we can do beer.
Okay.
Blue ribbon.
Pepper.
Oh my god.
We're not doing that. Okay. Here's my usual axes, right? And I guess I should dot that one. And I should dot this one.
The top part was fine.
And that one should also get dotted, because that's all inside there, right? You see this? So, can starts at z is -1, goes 4 units up. What does that make the coordinates of this point right here? 0, 0, 3. Good. Awesome. How about the coordinates here where it pierces this wall? That's where the x-axis.
Radius
0,
1.
0.
So
0, 1, 0. All right?
That's the x-axis.
so that's on the y-axis.
Yeah,
so
that'd
you
be
put
where
on
it hits the
axis.
y-axis, right?
Oh, so 1.
So 1, 0, 0. Okay.
Though since the
Yeah, no worries. I'm standing in your way.
but since
Okay.
the radius is 1, it would be 0, 1, 0 on the
Yep.
other axis.
Yeah, Kez was totally right on the y-axis. You just couldn't see because I was standing in the way. Cool. Check. Okay. Equation for this thing?
Well, you can turn the x squared plus y squared into r squared
Which x squared plus y squared?
inside the sign.
Oh, okay. So,
Convert the function to cylindrical.
okay. So, let me just write down first. We'd have the triple integral over w of f of x, y, and z. d z, dy, dx, or some rearrangement thereof,
Where are you
right?
getting this 003 from?
Oh, that's just me fiddling with the height and the radius.
How do you do that?
So they said it starts at z is -1. It's 4 tall. So the top's going to be at
3.
-1 plus 4, 3.
Okay.
Right, so the top of this is living in the plane z equals 3. The bottom's living in the plane z is -1. It's radius 1, right?
Yeah, so, okay.
So if it's centered around the z-axis, 1 out from the radius where it hits where the x-axis comes through it, right,
Okay.
is going to be at 1, 0, 0. So fundamentally, I'm trying to calculate the triple integral over w of f of x, y, and z, d usual Cartesian stuff, right? That's probably inconvenient here. In fact, they told me to move to cylindrical anyway, so let me do that. Alright, Kaz, now tell me about f in terms of...
Well, x squared plus y squared equals r squared, so you can just turn the x squared plus y squared into r squared, so you have sine r squared.
Okay, cool. So f, rephrased in polar, right, is sine of r squared. And then what else do I need there?
R,
R.
D.
I need an r, and then I need some order, right? This is going to be dr d theta dz, right? In some order. You guys see that? I still get to pick that order, right? That's
Yeah.
not something that cylindrical forces on me. What else? What do you start with? What's next?
No, I would think Zeke should go first so we could smash
It
it.
doesn't matter at all.
Smash-
So, let's see. Yeah, let's do Z first. Okay, so if we're gonna do Z first, where do the Z's start?
Z starts from
-1. Where do they go to?
-3.
3. Are they super consistent?
Yeah.
Yeah, I mean they all look like this, right? All the Z
No
slices,
change.
they just start at the bottom of the can, they go to the top of the can. That's why cylinders are easy with cylindrical, right? Okay, so that's DZ. What else is? So once I got DZ, what do?
You smash it.
Smash it.
Once a circle.
Okay, so then I'm operating in X, Y, right?
Well, x squared plus y squared equals 1 now.
Yeah, so really I should be operating in polar, right?
Yeah.
So this is 1.
R is 1.
So where do the R's go?
0 to 1.
Perfect. 0 to 1. Do you want to do them?
Why don't we do them last because then that'd be easier.
Well, you'll have numbers for theta, won't you? 'Cause you'll have
Yeah,
the
zero.
sign.
We'll do R last.
Okay.
It doesn't matter at all.
Okay.
How about the thetas?
It's 0 to 2
2
pi.
pi.
0 to 2 pi because it goes all the way around, right? So because all these are constant, right? It didn't matter which order I did them in. You guys see that? If I had had some kind of wobbly cylinder, right? Or part of it, or like funny planes cutting through it or something, then this order would have mattered a lot more. But here, really, any order flies, they're all exactly the same. Your bounds will even be exactly the same. You guys see that? Okay, so execute this for me.
Oh,
Can I say good enough for this?
yeah.
Did they ask for setup or solve?
They said evaluate, but I can't
Yeah.
want to.
So this isn't super hard.
No,
It's
Why isn't
not.
it super hard?
because sign is easy.
That's all a constant.
Yeah,
at the
it's just
moment.
a constant.
Yeah, all this stuff is constant with respect to both z and theta, right?
Yeah.
You guys see that?
Z times
So I could really. Do you guys remember the trick?
factor out.
Yeah.
Is
factor
this
out
an
factor.
example for the trick?
Yeah.
Because it's not adding, nothing's being added.
Yeah, nothing's being added, right? So I could think about this as
Uh,
like some function h of r
yeah.
times 1 times 1. And think about 1 as
One that.
like g of theta, right?
Uh-huh.
And think about the other one as,
G. The 8 F Z.
yeah, I already have an
Oh, okay. Then.
f with a hat on it of z,
Okay.
right? So then I can use my trick. I can break this into the integral, what was the one with the r's?
0 to 1.
0 to 1 of sine of
R squared.
r squared times
R dr.
r dr. And then I want to take that whole thing, right? Multiply by,
0 to 2 theta.
that's just 2 pi, right? That's your theta bit. And your z bit.
This.
Perfect. 4.
Yeah.
Okay. So that leaves me with really only one thing to do.
We got the 4 from.
I got the
Um,
4 from 3 minus 1.
Oh,
You're gonna have to do a U
3 minus, okay.
substitution.
Yep, so let's do a u substitution. So we're going to let u be r squared. So then du is 2r dr. Okay, so I need a... Oh, is that what you guys do?
What
Okay.
do you do?
Personally, I would throw a 2 in there and a 1/2 out here.
Yeah, we've done that.
and then all this jazz is du.
It's not
Yeah.
really
We usually just solve for what we have, then substitute half du in.
Whatever. However you get this, you should end up with what? The 1/2 and the 2 will cancel, right? So I'll be rolling with 4 pi times the integral of
Sine
sine of u du.
still 0 to 1.
Yeah.
Ah. Why is it still 0 to 1? Why is that surprising? Yeah, this happens to be one where it doesn't change when you square it, right? Really, the bounds don't change because when when r is 0, u is 0. When r is 1, u is still 1. Okay, what do I get when I evaluate sine of u?
Negative cosine u.
Okay, so I got the 4 pi times cosine of u evaluated from 0 to 1.
Mm. Well,
Or pi
are-
minus cosine.
Isn't it negative?
4 pi
cosine?
minus.
The integral of sine is
Well, that's negative cosine, isn't
Yeah.
it?
thank.
So it'd be,
Negative cosine 1 minus.
So I got 4
Oh, plus
pi
1.
times negative cosine of 1 plus cosine of 0.
Which is just 1. For
Okay.
cosine 0.
This base is 1.
But we don't know what negative cosine 1 is.
Yeah, I don't know what cosine of 1 is. It's some constant. So I got 4 pi times 1 minus cosine of 1.
Yeah.
Check done. So what does that represent?
The volume. In Cartesian.
Negative.
Oh.
So what was different between this one and the other easier examples I've done?
This involves an area underneath.
So
No.
It was,
So close.
The other one, we just solved for volume, while this one has an equation. So, like,
Yeah,
the
this
triple integral of
density
1
function.
radials.
yeah, so this one had a density function, right? F.
Oh.
That was given by the sine of the radius squared for some reason. So yeah, this would be the mass, right, of the cylinder with that density function.
Oh, so this is a
Does that
mass.
thing make a great deal of sense as a density function?
No.
Why would I be worried about using sine of something as a density function?
Yeah, the oscillations.
It alternates. Specifically, it goes
Positive, negative.
negative sometimes, right? Which is a bit weird in terms of the density.
So this is a density function?
That's the interpretation I would have. However, I would be a little careful with that, right? Because negative values in your density function are a little bit strange.
Just jump to charges instead.
Yeah. So think about this as the total charge or the total buoyancy or some other kind of total something or other.
Okay.
Cool.
Mm-hmm.
On this one, it should be noted, by the way, that this thing is actually positive in there, right? Because I'm going out to a radius of, erase my picture. I'm going out to a radius of 1, right? Sine's still positive for everything under 1. So I don't have that negative behavior problem here.